Welcome to the discussion on oxidations with chromium 6 reagents. Chromium 6 reacts with almost all oxidizable groups. During oxidation, chromium 6 is reduced to chromium 4, the most stable oxidation state of chromium. Chromium 6 oxide, sodium or potassium dichromate, chromic acid, chromyl chloride in CCl4, which is known as Etodd reagent, chromium 6 oxide with sulfuric acid known as Jones reagent, chromium 6 oxide with pyridine known as Collins reagent, pyridinium chlorochromate, pyridinium dichromate are some of the chromium 6 reagents used for the oxidation of organic molecules. Oxidation of alcohol with chromium 6 oxide. This reaction involves two steps. The first step is the fast step where alcohol behaves as nucleophile. Oxygen with its lone pair attacks the electrophilic chromium of chromium 6 oxide. Since it is a reaction between a nucleophile and electrophile, it takes place at a faster rate. In the second step, a base molecule breaks the CH bond and abstracts a hydrogen from this, and it results in the formation of a carbonyl group. If the alcohol taken is a primary alcohol, we end up with an aldehyde. If it is a secondary alcohol, it gives a ketone. The step 2 is the slow step, that is a rate determining step, since it involves breaking of CH bond. This is proved by kinetic isotope effect. When this hydrogen is replaced by deuterium, the rate of the reaction decreases to a greater extent. This is proved by taking isopropyl alcohol and the deuterated isopropyl alcohol for oxidation. The deuterated alcohol is oxidized at a slower rate. This proves that the carbon-hydrogen bond breaking step is the rate determining step. Pyridinium chlorochromate. E.J. Corey suggested PCC, pyridinium chlorochromate, for oxidizing alcohols. This PCC oxidizes primary alcohols to their corresponding aldehydes and secondary alcohols to ketones. The advantage of using PCC is it oxidizes primary alcohols only to aldehydes. The aldehydes are not further oxidized to carboxylic acids. This pyridinium chlorochromate reacts only with the alcoholic OH and it does not affect the other double bonds present in the molecule. Pyridinium chlorochromate is prepared from chromium 6 oxide. Chromium 6 oxide is treated with hydrochloric acid, ends up with chlorochromic acid, and this on treatment with pyridine forms pyridinium chlorochromate. The mechanism of oxidation of an alcohol with PCC is given here. I have taken a primary alcohol for the oxidation with chromium pyridinium chlorochromate. So here the alcohol behaves as nucleophile and it attacks the electrophilic chromium of PCC. And it results in the formation of a product that undergoes a SNI reaction. The minus charge on oxygen comes back to form the double bond, pushing out the chloride. The chloride that comes out behaves as a base and removes a hydrogen from the carbon which is possessing this oxygen. After the removal of hydrogen from here, it ends up in the formation of a carbonyl group. Therefore, the primary alcohol is oxidized to aldehyde with pyridinium chlorochromate. Here are a few other examples for the oxidation with the PCC. Geraniol, a terpenoid, a primary alcohol, is oxidized with the PCC to form the corresponding aldehyde geraniol. In the next example, I have given a secondary alcohol. This secondary alcohol reacts with the pyridinium chlorochromate along with sodium acetate. Pyridinium chlorochromate is highly acidic and it is buffered with the sodium acetate. So PCC buffered with the sodium acetate gives the oxidized product a ketone. The secondary alcohol is oxidized to ketone. The same secondary alcohol with pyridinium chlorochromate and hydrochloric acid in dichloromethane gives a different product. How are we going to account for the formation of this product? Let us see the mechanism. This alcohol molecule reacts with the pyridinium chlorochromate, undergoes oxidation to form a ketone. This ketone undergoes an ene reaction as I have shown here to give a product which is a olefin. This olefin is a less substituted olefin, therefore it undergoes rearrangement which is an isomerization to form a more substituted olefin. Here is another example for the oxidation of a tertiary alcohol. This is a tertiary alcohol, at the same time an allylic alcohol. When this is treated with pyridinium chlorochromate, we are getting a different type of product. Let us see what happens here. The tertiary alcohol, as usual, reacts with the pyridinium chlorochromate as a nucleophile, leading to the formation of a product here. And this product undergoes a co-rearrangement. This is the product obtained by co-rearrangement. So after this co-rearrangement, we have got a O minus here that abstracts the acidic hydrogen from here, that results in the formation of a carbonyl compound. We can see here the carbonyl group is not formed in the carbon which was originally containing the OH group. Oxidation of alcohol with chromic acid. Chromic acid is obtained by dissolving chromium 6 oxide in water. This is chromic acid. This chromic acid is obtained in other ways also. Sodium or potassium dichromate, when dissolved in sulfuric acid also, we are getting chromic acid. How do we get chromic acid from sodium or potassium dichromate on treatment with sulfuric acid is shown here. This chromic acid oxidizes an alcohol, a primary alcohol, to aldehyde, and that aldehyde further undergoes oxidation to carboxylic acid, and it oxidizes secondary alcohols to ketones. The mechanism is shown here. First of all, the alcohol behaves as nucleophile, attacking the electrophilic chromium of chromium 6 chromic acid, resulting in the formation of a new product. From this product, water molecule removes the most acidic hydrogen, leading to the formation of a carbonyl group. Here, water molecule is behaving as base. Therefore, this oxidation of alcohol with chromic acid takes place in two steps. The first step is the reaction of alcohol as nucleophile with the electrophilic chromium, which is a fast step. Second step is the slow and rate determining step, where the CH bond is broken by a base. When a primary alcohol is oxidized with pyridinium chlorochromate, it ends up with an aldehyde. But when the same primary alcohol is treated with chromic acid, first of all, the alcohol is oxidized to aldehyde and it is further oxidized to carboxylic acid. The oxidation of primary alcohol with chromic acid is given here. It takes place in two steps. Alcohol behaves as nucleophile, attacking the electrophilic chromium, resulting in the formation of an intermediate. From this intermediate, water molecule, which is behaving as a base, is removing the most acidic hydrogen by breaking this CH bond. That results in the formation of an aldehyde, but the reaction does not stop here. Aldehyde continues to react further with water to form geminal diol. Now once again, there are two alcoholic OH groups in this product. One of the alcoholic OH groups undergoes further oxidation with chromic acid to become a carbonyl group, that is carboxylic acid. Therefore, a primary alcohol is oxidized to only aldehyde with pyridinium chlorochromate, whereas the oxidation of the same primary alcohol with chromic acid ends up with carboxylic acid. Thank you.